Hey, I have here another integral on the board from the MIT integration bee. This was from 2022. This was quarterfinals, round 2, problem 1. We have the integral of arc sine x, arc cosine x, dx. Okay, and this is kind of similar to an integral that's really common where we just have arc sine or we just have cosine. But the difference here is where we have these multiplied together. Well, if we just had one of these functions, it would be the case where we'd want to use integration by parts. And I'm actually going to do the same thing. We're still going to use integration by parts on this. It's just going to be a little more lengthy. Before I get into the integration by parts, I just want to look at the derivative of each of these functions. Okay, so we have well-known derivatives for each of these, and they're really similar. Of course, just the arc cosine is just the negative of the derivative of sine. And what I'm going to do for integration by parts, we'll set this up using the DI method, tabular integration. We'll just have two columns, one to differentiate, one to integrate. And rather than differentiating one and integrating one, what I'm going to do is we're going to differentiate both. And again, this is similar to when we just have one of these functions because we know how to differentiate, but it's harder to integrate it. And to integrate, I'm just going to integrate 1 here. We'll just kind of create a 1 so that we can integrate that. And so, of course, the integral of 1 is just x, and then we need to differentiate this using the product rule. So I'm just going to do this derivative down here. So for the product rule, we'll take the derivative of arc sine first, which is this. So we're going to have 1 over square root of 1 minus x squared. And then we'll just have our arc cosine. Then we'll have our arc sine, and then we'll have this derivative, which is going to be, let's just write it down here in the denominator. So I'll write 1 over 1 minus x squared. I'm just going to take my minus and put it right here. And then putting that derivative together with a common denominator, we have this expression here. And now we already have part of our solution right here on the diagonal, right? So let's just write that down. We're going to have x arc sine of x, then times arc cosine of x. And then this piece here is going to be an integral. But I'm actually going to split this into two integrals. I probably should have just left it the way I had it before. So for what I'm going to do for the first one, we'll multiply minus we'll do the arc sine one first. So multiplying minus times minus, we're going to have a plus x arc sine of x over this radical. And then for this arc cosine one, it's going to be very similar. We're going to have x arc cosine over square root of 1 minus x squared. But I think what I'm going to do is I'm going to take this minus sign and just bring it into the denominator so I can write this as a plus here. And we'll look at it this way. But the nice thing about each of these integrals that we have over here before we finish it off is each one of these is actually in really good shape for a u substitution, just looking at knowing the derivatives, right? So like, or for the first one here, I'm going to call my u in this just arc sine. And so when I take the derivative, our du value is going to be just 1 over, well, we have it right here. It's going to be 1 over 1 minus, radical of 1 minus x squared dx. So that means we have our du right here. What about this x though? Well, because this is an inverse, we can just rearrange this and write this as x is equal to sine of u. And one other thing I can do real quick while I'm here is just draw my triangle, because I want to get a value for what is cosine of u going to be. So if I draw this triangle, let's see, so our angle is u, and then we can write this like x over 1. So opposite over hypotenuse is going to be x over 1. Using the Pythagorean theorem, we can see that our third side is going to be just 1 minus x squared. So if we want to get cosine of u is just going to be adjacent over hypotenuse, and that's just going to be square root of 1 minus x squared. And we could go and finish this integral off, but this one is so similar, I'm just going to kind of do them side by side. So over here, just so I don't confuse my variables, we'll do a v substitution. And I'm going to say v is going to be equal to my arc cosine of x. We'll get our dv, and we know that value because we have it right there. And that's going to be square root of 1 minus x squared dx. And then again, we want a value for x, so what I'll just rearrange this again. Same thing basically, so x is going to be cosine of v. And then we also, while we're at it, we can get a value for sine of v. Now to get this value for sine v, I could go and draw another triangle, right? But you notice this triangle is going to be like basically the exact same thing with a v here. So instead of doing that again, we can see that sine of v is going to be just square root of 1 minus x squared. You could just pencil in a v right there and see how it works too that way. Pencil it in marker. Okay, now from here, we're in good shape to do our substitution. Our x value is going to be just sine of u, and this over here, and this dx over 1 minus x squared is just going to be our du. And then very similar over here. So our arc cosine value is going to be v, and then we're going to have cosine v dv. Okay, now I've summarized all these values that we just found on the last board over here on the left, and we just want to do these two integrals, which aren't too bad, but each of these are going to require integration by parts again, and I'm just going to use the DI method one more time here. So starting here, we'll do our DI method on this u sine u integral. So we'll set up our d and our I. I'm just going to differentiate u and integrate sine u. In doing that, we'll differentiate this 2 times. So we differentiate u, we're going to get 1. We differentiate 1, we get 0. Here we integrate sine u. That's going to give me minus cosine u. And then here, integrating again is going to give me minus sine u. And I think I'll just do my other side by side. We'll do another integration by parts over here with v cosine v. We'll differentiate and integrate. So I'm going to do the same exact thing really with v and cos v. So this is going to give me 1 and then 0. Integrating cos v, sine v, integrating sine v is going to be minus cos v. So then these last rows are 0 in both cases, so we don't have to worry about doing any more integrals. We can just start taking our answer on the diagonals, and let's see, well, we need to preserve this x part, so we're going to have our x, arcsine, our cosine. Then here on this first piece, we're going to have minus u cos u, and then here we're going to have a plus sine u here, because minus times minus is plus. Then over here, we're going to have a v sine v. Sorry, I don't want my v to look like a u, so let's fix that. And then here on this last one, minus times minus is going to give me a plus cosine of v. Okay, so now we're close. We just need to back substitute here, and we have all our values. So this is going to be pretty easy to finish off. So first for u, we're going to have just another arcsine. Cosine of u is going to be this square root of 1 minus x squared. Sine u is just an x, right? That's good. A v, what's v? V is arc cosine of x, and sine v is going to be the square root of 1 minus x squared. And then we just have this cos v at the end. Well, cos v is just x. So let's put that in there. And then I can simplify this just a little bit. So we're going to bring down this. I'm bringing this along for the ride. So we have our first part. Then from here, I'm going to factor out this square root of 1 minus x squared here, because we have it in 2 terms. So I'm going to write this as 1 minus x squared, and then we'll write it as arc cosine minus arcsine. So let's just combine these 2 x's we have here, and we'll add a plus c, and that's it, we're done. Okay, so as you can see, it was quite a bit of work, but it came out okay, not too bad. We just had to do integration by parts 3 times, and it came together okay. So we'll stop it there. Thanks everyone for watching today. Please like and subscribe. Have a great day.